I saw that the Islamic Center had shared the information again last night, so that was good to see.
Well, I think we are in good shape. I'm David Arnosti from Hazlitt Community Church Green Team. Welcome everybody to our coffee hour on geothermal energy. This presentation is being sponsored by Michigan Interfaith Power and Light, and we will be recording today, and the presentation will be available at the Michigan Interfaith Power and Light YouTube site. I noticed that their YouTube site also has a recording of the solar summit that our church hosted last March. And so you're welcome to visit that site in case you want to share this with somebody else. We're delighted to have two geothermal guests with us this morning, Rob Blackshaw from the Michigan Capital Commission and Dave Ferguson, Williamston homeowner and geothermal enthusiast. I'm going to share just a couple of slides and a 2-minute video on geothermal before we turn things over to Mr. Blackshaw. So the Hazlitt Community Church Green Team has sponsored a number of projects related to our mission for creation care, including the solar roof on our church, supporting our memorial garden with native plantings, and collaborating with community partners, including the University Lutheran and Islamic Center on energy efficient and solar. Rich Baumgartner, who is with us on the call today, is our chair and is available at the email shown below. When we hear the word geothermal, sometimes we think about geothermal as in Yellowstone National Park with geysers and super hot steam. And indeed, that is one meaning for geothermal. There are actually projects in the world that tap the superheated temperatures of underground magma pools. But geothermal has a much broader sense in most of the world. And we'll just take a look at a 2-minute video from the Department of Energy explaining how the warmth of the earth can be used to keep us warm in the winter and, interestingly, cool in the summer. So let's take a look at that. Right here.
We all want to save money heating and cooling our house or office, right? The answer may be under your feet, literally.
And cooling can come from the ground, below the surface, with something called a geothermal heat pump. You see, below the frost line, about 10 feet down, the Earth maintains a nearly constant temperature of 54 degrees. We can tap into this energy to provide heating in the winter and cooling in the summer. Okay, now here's how it works. Bury a loop of pipes, called a heat exchanger, just below the surface, and fill them with water or a water and antifreeze solution. During the winter months, the air is usually cooler than the temperature below ground. The solution circulates in a loop underground and absorbs the Earth's heat. This heat is brought to the surface and transferred to a heat pump. The heat pump warms the air, and then your regular heating system warms the air some more to a comfortable temperature. Finally, ducts circulate the air to the various rooms. Now, a huge benefit is that the geothermal system doesn't have to work as hard to make people inside comfortably warm, and you save lots of money on your heating bill. In the summertime, the system works in reverse. When it's hot outside, the temperature below the surface is cooler than the summer heat. So, the fluid in the loop absorbs heat in the building and sends it underground. The ground's lower temperature cools it, and it's circulated again and again. Now you're saving money on air conditioning. Now, this church uses a large geothermal heat pump to heat and cool the building. It has a very big parking lot, which lets it spread out its loop horizontally. But if you don't have all that space, you can go straight down and use a vertical loop system instead. Geothermal heat pumps can be used just about anywhere in the U.S. because all areas have nearly constant shallow ground temperatures, although systems in different locations will have varying degrees of efficiency and cost savings. The constant temperature of the Earth just below our feet is a sustainable resource, literally in our own backyard. It's a clean energy source ready for us to use, to heat and cool our homes and buildings while lowering our utility bills.
Okay, that gives just a quick picture of the topic, and I'm going to go back to our slideshow. So geothermal systems come in all different sizes. Some very large ones, such as Ball State University in Indiana, converted their heating and cooling to geothermal with thousands of geothermal wells and millions of dollars for this project. There are also a number of churches. The one shown in the video is Holy Cross Lutheran Church in Colorado, which installed geothermal just a couple of years ago. And the St. Michael's Lutheran in Akron, New York, that also installed a geothermal system. Notice the solar panels on their roof. I think this church must also have a green team. Now, turning to our state capitol, we're extremely fortunate to have Rob Blackshaw with us this morning to talk about work that's been going on here in Michigan. So the State Capitol Commission, as described on Mr. Blackshaw's LinkedIn site, is preserving the past, inspiring the future, and is responsible for preserving and designing and constructing building elements on the Capitol. And preserving the Capitol as well as keeping it up to date has been a real challenge. Mr. Blackshaw's education was here in Michigan, Central Michigan University, as well as a master's degree from George Washington. He has been active for decades in the field of maintaining historic facilities like our state capitol. And just a brief introduction to the project he's going to be telling us about is our state capitol was completed in 1879 when the ideas of heating and cooling were quite a bit different. Nowadays, with this new geothermal system, there's a utility center that's been added near the Capitol to coordinate this geothermal system. And there's a very large geothermal field behind the Capitol, which contains wells. And we're now going to turn things over so Rob can tell us more about how this project was conceived and the hurdles that they've come through, and now that it's started, how it's going. Rob?
Good morning, everyone. Thanks for the opportunity to speak this morning. This is a topic that I think everyone is excited about, and I'm pretty passionate about and fortunate to install this type of a system at the state capitol. Before we get into the geothermal, I think it's important to just do a global history of the Capitol from a material standpoint and to kind of explain how we really did get here. So as David said, in 1879, the building was built by the architect Elijah Meyer. It was really even before electricity was built. So there was a lot of gas fixtures in the building, and that took care of the lighting from a gas perspective, but they used what they call passive heating. So basically it was general physics used bringing in outside air from different points and general physics to run the air through the building. So about 6 years ago, we even discovered an area in the Capitol on the 4th and 5th floors where there is a steam pipeline that said steam supply line for summer ventilation. Now I say it slowly because I think everyone catches that steam supply for summer ventilation. Well, if you bring in outside air on July 4th and it's 90 degrees and humid, that air is basically just going to sit on the ground floor and the first floor. What they did, then they turned the steam pipes on the 4th and 5th floor in the shafts to 120, 130 degrees, and air naturally rises. So it actually drew that air through the building, and they call it a chimney effect or a stack effect through the dome. One of the effects of the dome still acts this way today. It naturally wants to pull the cooler air from the lower floors up through the building for natural ventilation. So over the years, they've considered keeping these intact while they've upgraded different types of HVAC systems and electrical systems throughout the years to keep up with the technologies. I can really get into great detail with that, but I'll kind of just give you a global overview. So let's jump to the late 80s and the early 90s. The building had been chopped up, floors added, kind of neglected, to the point where the state either had to invest a lot of money to keep this building or tear it down and put a state capitol on a different piece of property. And that was seriously considered. Fortunately, they realized the beauty of the interiors of the building, because inside our state capitol, we have 10 acres of hand decorative paint. So if you look at Capitol Square in this picture in front of you, you go from corner to corner to the other corner to corner and hand paint that entire square. That is how much hand painted decorative arts we have in the state capitol building. Well, during the restoration of the late 80s, that was really a big aesthetic upgrade. They did take care of a lot of the issues in the building, but it basically brought the grandeur back to the building of the Victorian decorative arts. And that's on display today. Anytime you come into the building, you will really see 6 different types of Victorian decorative painting in plaster. There's even original plaster throughout the building, which is now 140 years old. And now we have plaster, let's say, are 30 years old is our youngest plaster. So we've all heard the expression, be careful what you ask for, because you're going to get more than what you really wanted. Well, that happened here about 10 years ago, let's say. We wanted to do a decorative painting survey, which would have been 20 years after the restoration, to say, how has this aged? What kind of work do we need to proceed further? So we had decorative painters and plaster experts come in and did a complete analysis of the decorative painting inside. And sure enough, there's a couple $1 million of work that needs to be done. But before we went ahead and executed that work, we said, let's go on the outside of the building where the stone is and patch up some of the stones. 2 important things to know about the Capitol building: there is no proper vapor barrier like on our homes, and no expansion joints. So what that really means, we need to really be careful about the humidity that we introduce to the building, because the interior is going to expand and contract as the exterior does. And we have graphs and studies showing that is within single digits of percentage of the expansion and contraction in the building. So keeping all that in mind, we went ahead and did an exterior restoration, repainted the dome, and then I said, okay, let's get back to our decorative painting project. But we said, wait, before we do that, it has been 25 years since the restoration project. We should probably evaluate the HVAC systems in the building. We know that the life expectancy of a lot of equipment is 15 to 20 years, but now it's been 25 years, and we know by the time we finish our study, it's probably going to be 30 years by the time we replace that. So sure enough, we had engineers come in, architects and engineers, and we hired them from Washington, D.C., because we really needed them to evaluate a building that they've have evaluated before, like the state capitol. It's not just a high rise with drywall, ceiling tiles, and carpet squares. Again, we're talking about decorative arts, 140-year-old plaster, original marble floors, and brick shafts that have been there forever. So we wanted someone who had the expertise to come in and evaluate this building. Well, lo and behold, they did come back and said, we have good news and bad news. The good news is the building's not going to fall down, and your decorative painting, by the way, is beautiful. The bad news is your HVAC equipment, electrical equipment is really out of date. It's not code compliant, and we should really upgrade that. By the way, what are your utility costs? So we started thinking about this right away. The first answer was utility cost. I had that at my beck and call. Our annual utility cost average $800,000 a year. And our current HVAC system before this project I'm going to talk about, at its best was operating at a 60% efficiency. So if it was doing its best job, we're only 60% efficient. So we knew we had to do something. We don't feel we're spending taxpayers' dollars wisely. So as we got into the study of this building, we started looking at gas boilers, using the existing steam line, partnering with Board, Water and Light on their electrical. And then a few of us brought up, what about exploring geothermal? And as everyone knows from the little video that David just shared with us, geothermal is a natural energy that we can use. It holds a natural temperature. And it is a little bit more expensive on the onset, but you're going to make up your money really quickly in utility cost. It's sustainable, it's green, and it's better for the carbon footprint as well. So to make a long story short, we decided that our utility delivery would be, we'll keep our electricity and we're going to use geothermal for our main HVAC. Now we do have a little bit of boiler, which is natural gas heated in the building, but that is a redundant backup, and that also handles some of the snowmelt systems we installed under the sidewalks. But in order to handle our building, we had to put in 224 wells at a 500-foot depth, 1.5-foot pipe, which is an HD pipe, a high-density plastic pipe that went down. It's a closed loop system, so it's one piece of pipe going all the way 500 feet down, coming 500 feet back up before it tied back into a lateral system. So these are horizontal wells that go all the way down, and then it came up, ties into our lateral system, which then runs to our utility underground plant, which is called the CUP, Central Utility Plant, where we house all of our heat pumps and stuff as well. During the middle of this project, it was considered, we are concerned about how the public was using the Capitol building itself. Caterers are still coming in, there are parties in there, there are things get leaned against the wall. We had 200,000 school kids coming through a year, plus another 150,000 people coming in using toilet rooms during rallies and events, and the building was starting to show its wear again. So it was decided to add a new underground facility. We are calling it Heritage Hall. It's a 40,000 square foot facility, which is just on the west side of the building. On the north half, right above this geothermal field, that would be the new entrance for all the students in the facilities. We've also put meeting rooms in there for catered events and such. So the main goal was to do two things: get the main flux of traffic, uncontrolled traffic, out of the Capitol to protect the decorative surfaces. And with today's day and age, security and safety are always of concern. We now have a controlled entrance for safety and security. So now when the school kids come, right now they are dropped off at the library and museum, have to walk about 1/4 mile, or the buses drop them off on Walnut Street and they have to walk 1.5 blocks, sometimes through the rallies and events to get into the building. It's usually a pretty safe environment, but with today's, as all we witnessed last year, the rallies are getting a little more rambunctious, I'll use that word. But the safety and concern of all of our patrons and occupants is there. So we're trying to find areas to bring people in the building that are safer. And as I mentioned, now the school buses will drop the kids right off at the door. They walk basically 25 to 30 feet. They're in the building. They're greeted by Michigan State Police security, and our tour guides brought in there, given orientation, and ran through the building. So the first challenge was, okay, we're getting ready to put an underground facility, which goes 40 feet into the ground on top of our geothermal field. Well, we hadn't executed the full installation yet, so we had the opportunity to modify this system. And sure enough, we did. We placed the footprint on top of wells, and we chopped up the first 50 feet off and then refused them to feed into the building. But we had to add more wells to handle the HVAC capabilities of the new facility as well. So we added more wells to cover that. So we'll now have a total of 272 wells that go to a 500-foot depth that'll all go to the central utility plant where the heat pumps will take care of it. A couple things happened when we went down to that depth. Number one, we went through the aquifer that the city gets most of its water from. So we did have the groundwater board management of Ingham County, Eaton County, and the city met with us a number of times. And I know from my perspective, I'll just speak for myself at this point. There's no way in the world I want this system to fail and leak glycol into the groundwater. So we did a lot of research and study to make sure that does not happen. Number two, we partnered with them because there were some geothermal experts on these water boards and have dealt with systems before. They helped us decide the closed loop system is the best. We put in a thermal grout, which is called bentonite grout, that helps conduct the energy at the lower levels. And it also contains it a little bit more. So if there is movement between the ground and the open aquifer, the water rushes under the ground like a river. A pipe is contained, it won't bend and break and move if big rocks get in the way. It actually acts as a coat of help. The next thing that we did was consider the type of glycol that we used. So prior to this geothermal system, we did have some glycol in some lines, and we used polyethylene glycol. That's sometimes toxic. If it gets into the ground, it is messy. But fortunately, the only thing we had was 10 or 15 feet down, so you could actually remove the soil and mop up the mess if it became an issue. But again, we're going 500 feet into the earth now through an aquifer that supplies a water supply for the greater Lansing area. It was great concern to make sure that we really did this the right way. So we decided to start using a polypropylene glycol, and it's a vegetable grade. And it's a couple things to mention about this. Polypropylene glycol is vegetable grade, and it's used in a lot of additives in foods and stuff today. I always say this as a joke, and everyone that works with me laughs, but this is the same glycol that McDonald's uses in its milkshakes, believe it or not. So people do ingest this. The other good thing about it, at a 50 feet dissipation rate. So let's say we accidentally do have a leak and it does get into the aquifer. Within 50 feet, it is so dissipated that you won't even know it was in the water because of the amount of water that flushes and washes it out. But again, even at this level, it is safe to put in the water supply, but it dissipates to a rate you won't even notice it after 50 feet. Again, we went to extra lengths to make sure this doesn't happen, or hope it never happens. The pipe that we put in there is the same pipe that Consumers Energy used on their gas lines now. It's a 50-year warranty, but everyone knows it's 100 to 120-year life expectancy. We are still have water lines that we've replaced that are over 100 years old that supplies water to our building. And we know that the pipes that we have are better materials than what that is. And the piping here has lasted 100 years. So that's all great news to us. So to get back to the utility in the building is $800,000 a year. We already know that when we're finished and upline this project, it's going to be a 30 to 40% savings right off the bat in the first year. So you think of our $800,000, and I'll use the smallest figure of 30%. That's a $240,000 savings immediately in the first year once we turn this thing on. The other thing that we've done, speaking of energy, as a side note, we did retrofit all of our electrical fixtures with LED lighting on the interior and exterior, and that should help reduce our electrical costs as well. So again, we are looking at $250,000 savings in energy alone in our first year, and we can use that to pay back the project on, as a return on investment, and use it for other things to restore the building. But overall, if you look at it from a global perspective, we're making the wisest choice in our minds by keeping it green, making a sustainable energy, and helping to reduce the cost of the taxpayers' dollars. We take that very seriously. I'm a taxpayer just as everyone else, and I want to look at my neighbors in the eye and be honest and say, yes, we're doing everything we can to save the money. We know it costs a lot of money to maintain this building, but we take everything into consideration. So as we say, we inspire the future. That's part of our thought process. We're preserving a 140-year-old building, trying to inspire the future by making sure we're code compliant, using the latest technologies, and moving forward. The greatest thing about using the newest technologies, I feel this technology has been here forever. We're just really starting to realize how to utilize it more efficiently. I mean, the ground has been 55 degrees under 10 feet, probably for a long, long time. If we've all gone up north or gone to areas with our grandparents or our parents in the past, they all had a root cellar or a storage cellar. Well, that's 55 degrees. That's funny. You think of the wine industry in northern Michigan. They have their storage cellars at 30 feet and 40 feet in the ground, and there's no utility, but it's a natural 55 degree storage temperature, which they desire. So a lot of those things are really clever in our minds, And it's fun to mention that as a comparison to just realize we're utilizing a technology or an energy source that is already there. I could go on and talk about this for a long, long time. And what I like to do when COVID lightens up and more people are vaccinated, I would like to invite you guys to come through. I can walk you through, look at this. We are right now energizing our, what we call the cooling season system. So come April, when we turn on the air conditioner, the entire air conditioning system will be on HVAC geothermal. And we are really proud of that. It's taken us a while to get there, but all the headers and the equipment are being installed at this point, and it is really a massive undertaking. And I'd really like, picture always does say 1,000 words. And as we were even setting up this presentation today, I talked with David. I said, I really am not sure what pictures to show everyone because there's just so much detail involved with the planning and execution of this geothermal system at your state capitol. But again, I welcome every single one of you to come on a tour with me in the future. We can set that up on Saturday or Sunday or even after work on a weekday. I love showing off the building to everybody. It is a beautiful thing. So I'll leave it at this point and pass the torch on to the next person. Thank you guys very much.
Thank you so much, Rob. Fascinating and really great presentation. If folks have a question, you're welcome to speak up now. Just unmute yourself.
Yes. I was just curious why the 500 feet depth. Is that just to increase the heat exchange volume?
Two things. That's a good question. Yes, to increase the heat exchange volume and to handle the actual volume of the building. So we is more of a volume because we were confined on our space that we use inside of Capitol Square. We could have went more lateral, but as it's explained in the video right before my presentation, we are limited on space. So the best way to make up that space was to go down into the ground. So for the volume, yes, that was the answer.
272 wells, I don't get it.
We have 272 wells that go down into the ground at 500 feet. Each well is a 1.5 inch pipe that loops down and comes back up.
Oh, I thought you said 1.5 foot.
And that handles the volume that we need to heat and cool the building.
So what you mentioned the annual savings. What is the investment, ignoring the new entrance and that, just for the geothermal part? What's the cost?
So when we looked at replacing the energy systems in the building, the geothermal was an additional $3.5 million above any other system that we would have replaced. So if you just take, let's say we save $250,000 a year, it's really a 10-year return on investment, 10 to 12-year investment. And we thought that was pretty good because everything after that, it's, I don't want to say it's free money, but it's money that we actually did save. So, and it's sustainable. There's no energy cost using it in the future. There's not oil. There's not electric rates that are going to go up. So we really thought it was a great idea to try this or to do this.
Well, there's an operating cost of running.
The operating cost to run the geothermal or the operating cost to run the building?
He's asking you. Operating costs of what?
Of running the geothermal.
Well, that's a good question. I mean, I could use the energy cost that we spend each year as the operational cost. We do have preventive maintenance that we maintain our equipment on, which is handled through two ways. I have a couple on-site staff and I use a mechanical company as a hybrid to come in and do tasks for us as well. We found that to be pretty economic and efficient for us. But those costs would be there regardless of what system we had. I don't know that exact dollar figure right now at the top of my head. I do know it's close to $200,000 to $250,000 a year to maintain the HVAC electrical systems in the building from a labor and material standpoint. And that's probably pretty close figure.
A question about the new Welcome Center. When
yes.
Children visit the Capitol, will they also be learning about the energy system that the Capitol uses? Will there be displays or descriptions of the geothermal?
That's a great question. And the answer to that is yes. When they come into the Heritage Hall, they'll be going to an orientation room And then they're going to go down a hallway we're going to call Exhibit Hall. There's going to be 5 exhibits. It's really focused on the history of the Capitol, how the Capitol functions, because we need to recognize we're here supporting the legislative process. So we need to make sure that when the school groups come in, they get their government credit for their education. But we are having some panel and talking about the energy systems that are used in the Capitol and a small history. So we'll talk about passive energy, electricity, gas lighting, all the way up to geothermal. So I'm working with our historian and our tour guide director to make sure that we have panels that explain that in a brief but concise method.
Thank you very much, Rob.
You're welcome.
I had a couple questions with the going down 500 feet for the closed loop. At that depth, does the ambient temperatures increase quite a bit?
It's all sustained. It's around the same, but what it does, there is a I forget what they call it, a thermal figure that they use. So when you send water down at a certain temperature, it'll come back up and hold its temperature longer. So a lot of the depth, again, was established to handle the volume of our building, as well as maintain the ambient temperature, whether it's 100 degrees outside or as cold as it is today.
Uh-huh.
I hope that answered your question.
Yeah.
What is the ambient temperature coming out of the heat pump after it's heated the air?
Well, when we introduce, the glycol will come out at 55 degrees. And when we push it to the building, it's 55 degrees. Once it gets to a distribution area, so let's just say my office, the cold water or hot water loop will get to what I call a VAV box, a variable air volume box. It'll go through a coil and either heat it or cool it based on that. So it starts at 55 degrees at the central utility plant. By the time it travels through the building with friction, the temperatures do rise. But then we have distribution points or fan coil units, VAV box, air handling units that can cool or warm the air before it goes on to human skin.
Well, I guess maybe I didn't ask the question correctly. This is a compressor-based system, right? Where you're compressing Freon to pull the 55-degree glycol as your heat exchanger, and then your output is a higher temperature because of the pressure of the Freon or whatever your system is. So you're not using compressors to generate the heat from the water coming out of the ground?
No, it's a glycol solution that runs through and is just basically pumped down. It'll naturally heat or cool, comes back in, and then it basically goes through the building as a loop too. So these temperatures in this glycol solution runs through the building. Once it gets to the air handlers or the distribution of variable air volume or a fan coil unit, there are coils in each one of those units that can heat or cool it. So there is no compressed.
Okay, so how do they heat or cool it?
The heat or cool has electrical coils in each distribution unit. Yeah.
Okay. So I have a real old system. I have a 35-year-old geothermal system, and mine uses a single stage compressor that pulls the 55-degree water out of the ground. It gets cooled down to about 30 degrees, but it generates 105 to 112 degrees of ambient air temperature coming out of the heat pump. So it's a different,
Gotcha.
My system is different than this one is. So, okay.
Yeah.
So that's probably a good point to transition. There are actually a number of families at Haslett Community Church who have direct experience with this. For a home unit, the heat exchangers also go into the ground. Oftentimes, instead of a deep well, they're attached to coils. The coils can be in the ground. If you're near a pond, the coils can be in the pond. And there are even open loop systems where water circulates out of a well and then is dispensed into a field or another pond. And one of those families then is the Ferguson family. And I'm going to switch over to Dave Ferguson now. You should be able to screen share if you would like.
Well, I don't have anything necessarily to screen share because everything that you presented, David, was pretty much all of my presentation. So But I will say that as opposed to the graphs that you just showed, our system runs, I think there's 5 loops that run out parallel to the ground, 500 feet. They're about 8 to 9 feet below the ground. So they're not coils per se. They're the same thing that the Capitol has, but instead of going down, ours go out next to the building. And I don't know that matters anyway, but they put it in, they installed it using the same sort of equipment that you see that they put in the underground cables when they draw one of those ditch witch type jobs. So they dug a little ditch out next to our house and then, drilled these holes out. And there was a guy out there with the probe to make sure that they didn't pop out of the ground, and they put them in. I think that, I guess I can say that our cost projections are the same as Rob's, that we're looking at 10 years. We thought it was going to be shorter than that, but the projections of the cost of propane, and we're out in the country, we don't have natural gas, we have propane. And at the time we put it in, we sort of panicked because propane costs jumped up to a little bit over $3 a gallon. And we had also looked at the situation where we weren't even sure if we were going to be able to get propane. And now propane is back down in the $1 a gallon. And so our savings, when I just did the calculations, are more like 10 years than they had projected 7 years. So the total cost of the system that we put in was in the $25,000 range, and that was in 2014. And we got a 30% tax credit on that. And included in the savings were the cost of replacing our heating and cooling system as well, in terms of the projections. So our heat costs have dropped down about $1,000 a year, I guess is what it is, from what they were before. And I think it's in the same range as what Rob was predicting, a 30 or 40% reduction. Now, one thing that I think is important for us to say is that we may not be like everybody else because we're on propane as opposed to natural gas, and also that we're in the DTE world, and DTE, the way that they handled the electrical savings was that under a geothermal system, you're eligible for a reduced electrical cost. I'm not sure what DTE is relative to what consumers or Board of Water and Light is. I don't think it's quite as favorable, because we got our first bill actually yesterday from DTE after we took our geothermal meter out and put it on the main meter, and that was because DTE also did not coordinate very well with our solar array, that they wouldn't allow us to transfer the solar savings into the DTE, into the geothermal meter. So we took the meter out, and we're now running our geothermal system on the regular electrical cost. And it's interesting, again, in terms of if you're looking at doing this in your household, make sure you figure all this stuff out, because one of the things was that, and again, I'm speaking to DTE, and I don't know how much that's the same as consumers or Board of Water and Light, but DTE charges a service fee per kilowatt hour used. And so the actual cost of the electric to run the geothermal per kilowatt hour was higher in the months where there was very low utilization, because the rate savings on the service fee were not the same as the rate, or there were no savings on the service fee under DTE's arrangement. And we tend not to use the air conditioner very much. And so we probably aren't getting the same savings that somebody that would keep their house, cooler than we do. We tend to run the air conditioner when it's really hot in the afternoon, and then just turn it off and open the window. But I will say that I guess I can answer specific questions on things. Oh, let me say that the differences that we've noticed is that the furnace runs more often than it does. I think this gets back to Rich's question, is that I'm not sure what the temperature is coming out of our furnace, but it's not as hot as it was when we had a propane. So the furnace will run more often. The air conditioner is very efficient. And actually the air conditioner is set up, or the air conditioning part is set up so that the heat that it's drawn out of the air is used to heat water for our hot water tank. We actually now have 2 hot water tanks. One gets some excess things and it feeds in. And so we get savings on hot water utilization, which in our household still is propane. And I think the other thing is that our system is designed so that it's most efficient if we keep the heat at a constant level. And that if the temperature increase in the household is more than 3 degrees, that the geothermal system will actually kick into a backup electrical system, which is not terribly efficient at all. It's a heat plate that'll run there. So they have advised us, and it all makes sense, that you keep the heat at the same level so that you're not constantly pushing the system to go onto its supplemental electrical thing. And I guess that's all that I have to say, because again, you did such a good job with your slides there, David, that kind of took all the things I was going to say.
Well, question, big or small, how long are the parts expected to last? I understand that the tubing underground has a long life expectancy, and the mechanical parts in the house or in the plant, how frequently are they likely to be replaced?
Well, I think it's the same as what the Capitol was looking at. They told us 30 years, and they gave us a 10-year labor and 10-year compressor warranty on the furnace as part of the price. And we've now had it for 6 years, and we haven't had any problem. There's a rattle. I'll tell you, there's a rattle in the furnace right now, and it stops every time they come out to look at it. And so, so something's, some piece of metal is banging against the side, but other than that, we haven't had anything. I guess the only other comment I can make is that the filters are a little more expensive than you'd expect, because for whatever reason, the filter is larger than you have in a normal furnace.
Dave, I think you mentioned this, but I missed it. How much area outside did it take for your pipes for the lateral system?
We have, they go out 500 feet in there. There's five out and backs, if that makes sense. So I don't know what that means in terms of things. It would certainly, the part for our house is probably as big as the parking lot on the side of the HCC building. I would say that's how much. And they told us that once we put it in, and that there's no reason that we can't plant trees over the top of it. It's 8 to 10 feet down. They said not to worry about anything. I will say, and Richie brought this question up too, is that somebody talked about, and we had this discussion with people about sort of ruining your system by running too much heat and not enough cooling. And they tell us that that's not the case. Nancy was aware of somebody
It was an extreme.
who was using a geothermal system to heat a greenhouse. And when they used it to heat the greenhouse, they never used it to cool, that they were just using it to heat in the wintertime. And that
Exhausted their field.
It lowered the average temperature of the ground outside. And in an extreme situation, you could ruin your do that and make your system inefficient. But it's not apparently something you need to worry about with ours.
I think on something like that too is the thing that I had heard from somebody that put one in probably 5 years ago that I worked with. He was told in August, use your air conditioner a lot to push more heat down into the ground so that you'll have it in the wintertime. and I think that is at 55 degrees, 10 feet down, that temperature is going to be there for a long, long time. Now, Dave, is your heat pump, is it a 2-stage compressor or a single-stage compressor?
I don't know the answer to that. I'm sorry.
Well, that helps, because that gives you a lot more heat transfer from whatever the coolant, the gaseous coolant, it's an ammonia based, similar. I keep saying the word Freon because my system is an old R22 Freon, which you theoretically cannot get anymore. But for some reason, my supplier still has access to us, but I haven't had to do anything to it for probably about 4 years now.
Well, ours was a two-stage Climate Master geothermal closed loop system.
Yeah, that gives you because it's a two-stage compressor, you get a lot more heat. You extract a lot more heat from your coolant that's in your coils outside. So you can chill that down to almost 32 degrees and still get over 100 degrees of heat out of your heat pump at the vents. So
Well, it's not 100 degrees coming out of our vents. So
okay.
And I don't know if that's the way that it's supposed to be. It's not 100 degrees.
Okay.
It's probably more like, I don't know. It's warmer than than 67 we keep the thermostat at, but
okay.
It's not 100 degrees.
So, and that's why they say when you're a heat pump, you can't use setback thermostats anymore. You have to keep the temperature flat all the time because it makes it overwork. It's very comfortable. The nice thing about it, it's very comfortable in your house all the time because you set it at one temperature and you just leave it there. And that's the nice thing about it. So
I'm wondering if,
One
oh,
comment,
go ahead, David.
I was just going to say one comment about one of the church systems. This St. Michael's in New York had an old-fashioned boiler. So they would have hot water circulating through the building to radiators. And they were able to connect that to their geothermal system. The water in their circulating radiators could be heated up to a hot enough temperature that old-fashioned radiators would still work. But for other kinds of systems, and I believe this is the Colorado, which used to have a gas-fired furnace that blows hot air around, just as many like in our church. There, you don't really need super hot water or super hot temperatures. If it's somewhat over 100 degrees, that's plenty warm air to warm up the building to a comfortable temperature. And it makes it a little more efficient. So you can put a geothermal system into a building that used to blow hot air that came from burned propane or natural gas. You still have all the venting and all the ducts and so forth. It's just that the source of the heat that's going into the air is coming out of the ground. Sorry, I think you had a question too. Was it Betsy?
David, do you know what the heat credit, if the credit is still 30% or not?
I believe it's still 26%. And the latest bill that passed in December extended the tax credit for solar and geothermal for another 2 years. Tassin, am I correct on that? I see Tassin Sardar here. He's on top of some of these issues.
Yes, it is. It is extended through end of next year for sure. Yeah.
So that was.
I know about solar. I'm not very certain about geothermal, but since you mentioned that, it must be together.
Yeah, I believe it applies there too. So for homeowners who put in such systems, they're eligible for a 26% tax credit, meaning that the actual cost is less than the sticker price.
Hey, Dave, could you bring up that slide that showed the 3 types of cooling things? Because I just want to explain to people, I have a 4th type of coolant, okay? It's similar to the open loop system, but it's called a pump and dump, where basically you pump the water out of the ground, and then the water you take is, if you have access to a lake or a wetlands, which I have a 2-acre wetlands on my property, I dump the water in the wetlands. And part of the reason why I was very concerned, this is in 1985 when I put this in, I read white papers on the concerns about, and this was with Freon getting into the aquifer. Although it was supposed to be a very low risk, I don't have the kind of money to do a toxic landfill cleanup. So I decided to do the pump and dump, so that what it did was it percolated through the ground down back to the aquifer. And if there was by any chance any Freon in the system, it would be filtered out as it went through the aquifer and through the limestone deposits that are in there. You think like, wow, that's a lot of waste. It really isn't, because when the worst case scenario for my heating costs in the wintertime, and so our house is 100% electric. So that includes lighting and everything. It's maximum of $200 a month. That's all we ever spend for all of our heating and stuff. And in the summertime, and in the months like spring and fall, it drops down really low, like below like $60 a month for total. Because a lot of times you only have to run that cooling system for a few hours every day. And then the other side effect of having my pump and dump system is in the summertime, I have a bypass valve that I put in, and I have a walking sprinkler in my yard, and I take my waste heated water and I water the lawn. So my theory is the hotter the day is, the greener my lawn looks for free. So just to let you know of that's a different system.
That's another green team project, is transforming our lawnscapes into natural plants, but that's for another day.
Yeah.
This is my
David, ours doesn't, just to be clear, ours doesn't quite look like those loops either, because our loops are not coiled, they're straight out.
Right.
500 feet and back. But it's the same concept.
Yep.
We bought the house we're in on 10 acres with a pond. We bought it 20 years ago, and it had a pump and dump system. Compressor died within a year, so we replaced it with propane because of the expense at the time. But the pump, my thought about that was that the pump underground, pushing water into the house for all of our water needs, was running through the system, and in order to be efficient, it had to be running at 6 gallons per minute, which was pushing a ton of water through the house and into the compressor in order to heat the house or cool the house. And it seemed to me that moving that much water with the replacement cost of an underground pump being, at least a couple of $1,000 just to pull the pump up and pull a new one on it, which we did have to do at one time, is moving a lot of water. So that seemed to be inefficient to me. Are you saying that works okay, and that is that one of the approved or recommended systems at this point in time?
So on my well, because they knew I was built, so I built the house and we knew it was going to be a heat pump. So we did the whole house is 6-inch walls to get better insulation, because they told me, if you build a house with 2x4s, don't buy a heat pump. It will never keep up with the heating requirements. Yeah. So we did it with 6-inch walls, and then we put the heat pump in, and the well driller knew that it was a heat pump, so he drilled our water well is 400 feet deep, okay? But the water is standing at 75 feet in the well casing, so the pump goes down to 100 feet. So it's only pumping water up from about 100 feet. Now there's a wonderful side benefit to having that deep of a well. You have naturally soft water. You don't have any hardness to the water at all. So it eliminates, I still have a water softener to take a little bit of the calcium in it out, but it hardly works at all because it's naturally soft water. Now because I've been going for 35 years, I can tell you another side effect of 35 years is naturally there's iron in the water, and slowly iron is building up on the inside of my pipes through the heat pump, because that goes through 6 gallons a minute, and so I've noticed there's probably a 32nd of an inch thickness of iron deposits on my pipes. And this last year I had a problem where a chunk of that broke off and it jammed one of my water valves open, and I had to replace the water valve. So that's the other thing about doing where you're consuming a lot of water, where like Dave's, because he's just recycling the same water, he probably will never get that buildup on the inside of his pipes like I do.
So I guess my question is, anyone that has knowledge of this would be helpful. Is the pump and dump system still something that the professionals are recommending as a possibility for those of us that have bodies of water next to our house? Or is the closed loop system really the only way to go now?
They offered us all three, in terms of that. And they didn't seem to me, it just seemed like certainly the drilling straight down is more expensive than drilling parallel to the ground the way we did. And we just never even considered, they made an offer of it as an option, and we just didn't think about it too much. So, and we dealt with Applegate, for what it's worth. But it-
But if you already have a well, then
We have a well, yeah.
you have to drill a second well in order to do that?
Don't know the answer to that.
Yes, you do. You have a separate well to discharge the water back in, and they have to be separated by a certain number of feet to do that dumping. Unless you're doing a loop, are you talking about a loop through a return well or a dump through a return well?
No, the dump goes out into the pond. So
Okay.
that is not a well. So we only have one well.
Well, if you're going to do a dump, you're good. You should be good as long as you have a deep enough well and you never have problems running out of water.
Right.
So
I have a,
Concern is our pond would never freeze, and I don't know what the, you know, I'm not sure how good or bad that is. You know, if your pond doesn't freeze.
Well, it freezes partially, but it doesn't freeze hard enough to have an ice skating party.
So in the winter time, the water you're going to dump is colder than the 55 degrees. Like mine comes out at about 40 degrees. It can't go below 40 degrees. Otherwise, the heat exchanger could freeze up. So it has controls in it to shut down the system if the discharge water gets below 40 degrees.
I see that there's a question from Leafers. They've raised their hand. Larry or Becky?
yeah, our neighbors, I believe, put in an air exchanger. So rather than geothermal, it's an exchanger where their unit is outside, but it does both the air conditioning and the heating. Do you have any comments or any folks have thoughts on that approach as opposed to putting in wells?
They are very inefficient below about 15 degrees outside. Compressors can't generate heat when the temperature of the air is below 15 degrees very well.
So these also involve so-called mini split systems. These are air conditioning units for the purpose of cooling that can mount on the side of your wall. And the difference between using ground heat or cool compared to air is ground can hold so much more thermal energy. So there's a great efficiency in dumping the heat in the summer into water instead of trying to push hot heat into 90-degree outside temperatures. So in terms of the physics, you save a lot of electricity by exchanging against cool water compared to hot air. But they are an increasingly employed technology that can work in some settings that's certainly more efficient than resistance heating. So we're almost at the top of the hour. Unless we have urgent questions right now, we're going to wind up our session. Geothermal is a technology that's been around about 100 years. But as we think about how to decarbonize our energy economy, how can we move beyond burning fossil fuels? Certainly geothermal poses some really interesting advantages. And as the source of electricity becomes greener, the system really has a great environmental impact. So once again, I'd like to thank our presenters, Dave and Rich, for talking about their geothermal, Rob for discussing the People's Project at the Capitol. Thanks so much. And join us again for another Green Team chat in the future.
Thank you for having me. Nice to meet everyone. And again,
Thank you very much.
when the COVID clears up, you're more than welcome to come down and I'll take you on a personal tour.
Thank you.
Wonderful. Can't
Thank
wait.
you so much, Rob. That's very helpful.
Good.